I'm going to move this a little bit lower. Any questions you may have, please? Anything that you like to start with? Anything you worked on? Anything you need help with? Any preference? What would you like to start with? Anyone, please?
Can you do an example of law of sines?
Yes.
With two triangles?
Yes. Perfect. Law of sines. Do you have an example for us?
No, I don't.
That's okay. Okay, this was in chapter 7. With law of sines. Law of sines. And let's choose. Okay. Anyone remembers the page number for law of sines? Is there a problem that you had on homework that you want to work on, or just any? Okay. So one comment I have on any triangle, so for example, if I have this triangle, let's say GMX. If I'm asked to find the angle GXM, which of these angles is that? Is it this, or is it that? Is it G, is it M, or is it X? And how do I know? Anyone, please say something, please.
X.
Yes, thank you so much. So always the middle one, GXM. This is the angle in question, just making sure. Okay, I'm sharing my screen again. Any preference with law of sines? We looked at this problem. You want to choose from here. Anyone? Please choose, or I will.
You can choose.
Okay. I'm gonna choose 25. I don't know what to expect. A equals 3, B equals 2, A equals 50. Perfect. First, we have to draw the triangle. Then we have to label it. A, B, B, C, C. Now I'm going to use the numbers I was given. I was given 50 degrees. I was given B equals 2. And I was given A equals 3. So it's side-side angle. When I see side-side angle, something comes on. A light that reminds me that this is the ambiguous case. The triangle may exist. The triangle may have only one option, or the triangle may have two options. This is the most difficult case, so to speak. Okay, so I'm going to start law of sines that says that in any triangle, oh, that's not good. I have sine A, which is 50, divided by A, which is 3, must equal sine B, divided by the opposite, which is 2. From here, I'll try to find sine B, and then, of course, angle B. Cross multiply, 3 times sine equals 2 times this. So, sine B equals 2 sine 50 divided by 3. I will calculate. Uh, 2 sine 50 divided by 3. I will not click enter. I don't remember what I did. Maybe I changed it to radians. No, it's okay. Always check. 2 sine 50 degrees divided by 3, and I get whatever. I don't care for this number because all I need is the inverse, sine inverse of this number, of the previous answer. Close, enter. I got 30.71 degrees. So B equals 30.71 degrees. Knowing that this is the ambiguous case, I will make myself a list. So case number 1 and case number 2. A cannot change. A is the same no matter what. B, 1, is 30.71. B2 will be 180 minus 30.71. How come? Here's why. .71 degrees is somewhere here. So this is 30.71 degrees. Oops, I don't need 2 degrees. So now a horizontal line, there is another angle that ends here and could potentially fit in a right triangle. If you want to approximate just because we want to get this over with, roughly 150 degrees. Will it fit? No, because 150 plus 50 is already 200. What about angle C? What is C? So the second option is not an option in this case. The second possibility is not an option. So I can go ahead and determine C, and there is no B and B1 and C and B1 and C1. So this will be 180 minus 50 minus 30.71 degrees. And that's angle C. I'm also asked to determine lowercase c. Let me stop and ask you if you have any questions so far.
I do have a question.
Yes, please.
Can you explain how you know there wasn't another triangle again?
Because
like
150 degrees plus 50 degrees, which is fixed, is 200 degrees. Then C must have a negative angle. There must be a negative angle, and that's not possible. So if B is 150 degrees plus 50 degrees, it exceeds 180. But this sum has to be 180.
Okay, I see it now.
It's
Thank
too,
you.
yes, it exceeds 180. That's why I didn't want to even bother to calculate exactly. So is that okay?
Yes, I see it now. Thank you.
Okay, so now we can determine C. So this is 130. I don't need a calculator. 130 minus 30.71, of course, is 99.29. So that's C, angle C, 99.29 degrees. So finally, we have that sine 50 degrees over 3 equals sine 99.29 degrees divided by lowercase c. Cross multiply and divide by sine 50 to find c. And that's final. And we solved the triangle. So lowercase c, 3 times sine 99.29 degrees. Everything divided by sine 50 degrees. So, oh, I don't need to use this actually. Okay, so we have 3 sine 99.29 close divide by sine 50. Oh, divide by sine 50. 3.86. So lowercase c, approximately 3.86, whatever the measurement unit. Any questions? So that was the law of sines. Which topic would you like to go on with?
Can we do the trig identities?
Yes. Any particular preference?
No, I would appreciate it if you just went over one of each, though.
Yes, of course. Where's my book? I lost my book. Okay, we want to look at trig identities. Chapter 6. Okay, so let's start with, I'm going to click here and move back for a trig identity. So this is the simple one with no extra trig identities, no sum, difference, double angle, or half angle. Just plain. Please choose.
Um, 66.
66. Perfect. Excellent. Sorry if we did it before. Maybe not. Hopefully not. So we have secant theta minus cosine theta over secant theta plus cosine theta equals sine square theta over 1 plus cosine square theta. Perfect. Please always explain or state where you start from. The only thing I can do here is just replace sine squared or cosine squared. Kind of, I'm tempted to start here. This appears to be more involved. So I'll say the left-hand side equals. What I'm thinking of doing is, of course, replacing secant by 1 over cosine. So 1 over cosine theta minus cosine theta, 1 over cosine theta plus cosine theta. The next step would be to get rid of the denominator. I don't like the idea, I accept it, but I don't like the idea of multiplying and dividing or multiplying top and bottom by the same thing, because this is a very specific situation, like this one. It's up to you. I'm fine with any method. But I prefer to write cosine theta and then multiply. So I have 1 minus cosine square theta. The same thing here, 1 plus cosine squared theta over cosine theta. I know how to divide two fractions. I copy the top, changing it because I see this, changing it into sine squared, because that sine squared is 1 minus cosine squared. We know that. Over cosine theta times, and I flip the denominator, and I obtain exactly what I want. Simplify, write 1. The reason why I write 1 is because some students write 0. So please understand this is not 0. You're simplifying, you get 1. Simplifying, you get 1. So this is sine squared over this, exactly what I was expecting. I will write it again, and I will write left-hand side, which means the left-hand side equals the right-hand side. I proved it step by step. You cannot involve this, so please don't write this equals this, and then the next step equals this, and then the next step, no, 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 no. So this is where we are getting. We're not assuming that it equals, right? So we start on the left, slowly but surely, we get the right-hand side. Let's see if we have questions on this problem before we move on to the next type. So this was just a simple trick. So we are going to look now at sum, difference, double, or half angle. Examples of trig identities with the sum or difference, double angle, or half angle. Any questions on these steps? Anything? Anyone, please?